Hello and welcome back. We are now going to start a new domain, which is web application security. This domain forms the cornerstone of cybersecurity. A lot of organizations today are worried about securing their web applications because that directly impacts their business. Thus, understanding this domain, the fundamentals of how web applications are architected and how to defend them is very important from a cybersecurity perspective. Before we delve into details, you must first understand how web applications are architected, what are the different components, and how do attacks traverse these different layers. So at one end, we have the clients, who are either using mobile applications or using web browsers to access your website. Now for our web application, it has two major parts. The first part is the front end. This is the part with which the user interacts. So this is your website. It majorly comprises of HTML code, but it may also include JavaScript and other scripting languages. So this is the website or the GUI that the user sees. Now the clients access our front end by using HTTP or HTTPS. As discussed previously, HTTP transmits data in plain text, and that's why it is not highly recommended. So it is always recommended to use HTTPS. Behind the front end, we have the back end, which comprises of the business logic layer and the database layer. We're first going to discuss the business logic layer. The business logic layer is the brains of your application. So it is the part which actually runs your code, which gets the requests from the front end. So basically clients, they make the requests to the front end. For example, they want to fetch some data, they want to view some results, and the front end in turn makes calls to the business logic layer, which includes application programming interfaces and the real code. Now there are different frameworks available for the business logic layer, including Node.js, PHP, and Java. So in a nutshell, the business logic is the core of your application. Hidden deep behind the business logic layer is the database tier. Now the backend comprises of the business logic layer and the database layer, but the database layer has been purposely hidden deep inside because it contains sensitive information. So your database may contain credential information, credit card information, or any other kind of confidential information which you want to protect. So that is why we hide it deep behind. So this is the third layer. And we don't want the clients to directly access the database. So client requests have to pass through the front end, the business logic, and then they reach the database. And it is in fact the business logic layer which makes the calls to the database layer to fetch data or to update records. Now there are different technologies available for databases. You can use MySQL, MongoDB, and there are several others. The key point to remember here is that whenever you have a vulnerability in your front end or in your business logic layer, that is your application server, the hackers are going to exploit these vulnerabilities to basically access your database. So it is the database that they are interested in because your database hosts sensitive information. So for example, if you have a SQL injection attack, it is going to pierce through the front end and the business logic, and it is going to insert SQL queries which basically extract data from your backend. We are now going to discuss an important resource for web application security, which is OWASP. So basically, OWASP is a non-profit web application security community. You can go to their website at www.owasp.org. It basically advocates secure software development. They have come up with a list of secure software development practices and recommendations, and they also have highlighted some of the core web application securities that plague applications today. So they provide a lot of guidelines on how to address vulnerabilities in web applications. Now, OWASP primarily focuses on the back end of a web applications. So basically, it's mostly how hackers can penetrate to your web application, can exploit your web application to access the back end. It contains a lot of free resources for practicing common vulnerabilities. And if you're going to work in the cybersecurity domain, it is absolutely mandatory that you're familiar with OWASP and especially their top 10 vulnerabilities. So the OWASP Top 10 is a popular term in cybersecurity. This is basically a document that identifies the top 10 most critical security risks faced by web applications. Now please keep in mind that this list is a dynamic list. It keeps on changing. So they do a lot of research, they collect a lot of statistics which includes the damage impact of different vulnerabilities, and then they classify the top 10 vulnerabilities which are most important these days. And it is important to keep in mind these vulnerabilities when you're designing your web applications or securing them. We are now going to have an overview of OWASP top 10 vulnerabilities. For some of the vulnerabilities which are very common, such as cross-site scripting attacks or SQL injection attacks, we are going to go into a lot of detail. We are also going to have some labs on them. But for the others, we still feel it is important as a cybersecurity professional that you should have an overview of how they work. Let's start with SQL injections. The basic idea of SQL injection is that you have some user input fields on your website, and instead of entering legitimate user input, the malicious attacker injects specially crafted SQL queries in those fields. So for example, if you have a username or password field, the malicious attacker enters a crafted SQL query in those fields, and then that query gets converted into a query which is executed at the back end on your database, and it extracts information from the database. This usually occurs due to bad programming, lack of user input sanitization. The next is cross-site scripting. The basic idea is that malicious scripts are inserted into websites. So say there is a discussion forum, a user creates a new thread, but instead of legitimate text, he enters a script. And now every time another user visits that website or that thread, that script gets executed, and it can cause all sorts of damage. It can steal session information or credentials and so on and so forth. Another one is broken authentication. The basic idea is that there are mechanisms or weaknesses that allow you to bypass authentication mechanisms of web applications. Now this could be, for example, default admin username or passwords. For example, you have a WordPress website and you haven't changed a default username or password. And basically it is a mechanism in which you can bypass the basic security authentication. Another one is sensitive data exposure. So usually your web application should protect sensitive data such as session information or passwords. But some websites do not encrypt this or protect this information appropriately, and the data is exposed. So basically malicious users, they can extract this information from websites. Another one is XML external entities. So the basic idea of XML is that it is not a programming or a scripting language. XML is just a way of formatting your data, in order to arrange it and put it in a file in a structure, so that if you send that file to any other web application on the internet, they know how to extract or parse that information. So it is basically structuring of your data. It's a very popular standard today, used by a lot of web applications, especially web applications which work on different platforms or different technology. So it allows a common medium of exchange. So say you have a lot of information about users and you want to send this information to another web application, you could perhaps structure this into XML files and then send them. And since the XML structure is standardized all over the world, so the destination would know exactly how to extract that information. Another common standard similar to XML is JSON. Now in XML external entities, the basic idea is to exploit weak XML parsers to disclose sensitive information. So the basic idea is that when an XML parser extracts information from an XML file, it should work in a secure way. However, in some instances, if your XML parser is not secure, it may accidentally reveal sensitive information. The next is broken access control. In this vulnerability, web applications basically fail to properly authorize the user after authentication. So the main difference between authentication and authorization is that authentication basically means that you provide your username and password and then you are authenticated, whether you're allowed to log in or access the system or not. Authorization comes after authentication, and it basically means that what actions can a user perform. So different users have different authorizations. For instance, an administrator may have a higher level of authorization, whereas a normal user may have lesser privileges. So in this vulnerability, the web application fails to properly authorize users, and the user performs things like URL modification, modifying the HTML code of the page, or changing the state of the application. Next is security misconfiguration, and this happens when you have improperly configured access to folders, files, or accounts. An example could be, your web application runs from web pages which are hosted inside folders, right? So normally any user who accesses your web page should not be able to traverse directories which are above or different than the public one. But in this example, you have vulnerability in which users are able to traverse different directories onto your system directly. The concept of serialization and deserialization is that whenever you have an object and you want to send that object to another system, for example, over sockets, so then you need to convert this object in your code into a byte stream. So consider it this way. So let's say you have an object which has different variables, it has different data structures and so on. But if you want to send this object over a network, over sockets, then you need to convert this object from that programming language into a byte stream, which basically means just bits. So we kind of flatten this object and we send it over the network. And at the other end, the destination kind of reverses the process and deserializes the object. Now in this type of attack, the user passes a malicious object which has been serialized over the network, and at the destination, when the destination tries to deserialize this malicious object, it gets compromised because the malicious object is structured so that whenever deserialization is done, it is able to access confidential information. So next is using components with known vulnerabilities. This vulnerability has recently made it to the top 10 list. It is a dangerous vulnerability because nobody wants to reinvent the wheel. So whenever we write web applications, we often tend to reuse existing components in order to streamline and speed up the process. And if any of those components have vulnerabilities, then those vulnerabilities will be inherited by your web application. A good example could be Docker images. So a Docker is a sort of a self-sufficient component which you can simply plug into your web application in order to speed up the process. Now recently, several Docker images, be it Linux or JDK based, they have been shown to have known vulnerabilities. So next is insufficient logging or monitoring. Ideally, web applications should have adequate mechanisms to appropriately log and monitor any types of accesses, errors, and problems. Now it should be noted that any of these debugging messages or error messages should never be displayed to the user because a hacker could then exploit this to find out more information about your system. However, this logging and monitoring should always be done at the back end, and appropriate mechanisms should exist to have adequate logging and monitoring so that you are able to detect attacks later on, carry out forensic investigations, and so on. So that concludes our lecture on OWASP.